All right, so this is a little bit different type of problem. It's a two-dimensional problem. It says 82 kilogram football player is running in the positive y direction, so like north, with a speed of 3.1 meters per second. A 96 kilogram player from the opposing team is running in the negative x direction, so like east, with a speed of 2.4 meters per second when the tackle is made. Assuming that the players remain together, they get stuck together, what is their speed immediately after the tackle? Okay? Now, let's not forget, momentum is a vector quantity. Direction matters. Everything we've dealt with up to this point is all in the same dimension. One's going to the right, one's going left, or like in the last problem, both going to the right. And when they're all in the same dimension, they can just add or subtract from each other. But in this case, they are no longer in the same dimension, they are in two dimensions. And we have to remember how we combine vector quantities. Okay? So, like with any vector value, what's true in one dimension has to be true in the other. So, conservation of momentum always said that the total initial momentum has to equal the total final momentum. But that's going to be true in each of the two different dimensions. What's true in one dimension has to be true in both. So the total momentum in the x direction initially is equal to the total final momentum in the x direction. And similarly for the y. Py initial is equal to the total py final. Okay? Now this one isn't so bad because the one is going perfectly horizontal and the one is going perfectly vertical. So all of the vertical momentum comes from this guy. All of the horizontal momentum comes from this guy. Okay? But these, this is how if we were seeing them go towards each other, how they would collide, and then they would move off in some direction like this. Right? But that's not how we draw vectors. We draw vectors that we're trying to combine, connected head to tail. So we have one moving in the positive y direction, and one moving in the negative x direction. Okay? So let's just call this P1, and let's call this P2. Okay? Now the total momentum, P total, is going to equal to the sum of P1 and P2. And you can use whatever notation you want there. But again, that's the vector sum, not the mathematical sum, the vector sum of P1 and P2. So how do we draw the vector sum? We draw the two vectors that we are combining, head to tail, like we just did. And then the combination or resultant is going to be drawn from the tail of the first, to the head of the last. So we're going to call that P total. So before we can figure out the speed of this new combined mass of football player, we're going to have to find what the total momentum is. So we have to take the vector sum of it. Now again, this gets a lot easier because one guy's going due north, one guy's going due west. So there's only one thing going in the x direction, and that is the football player that is going in the negative x direction. And he has a mass of 96 kilograms and a speed of 2.4 meters per second. And there are no other x momentums going on, right? So we're solving this equation here. The total momentum in the x direction is just, P1x, or whatever you want to call it. And since it has to be conserved, that's going to be the same value for the n. And for the y, we only have one momentum in the y here. And that's going to be that football player's mass, 82 kilograms, multiplied by 3.1 meters per second. We can multiply that out. So the answers of these two equations are going to be the total momentum in the x and the total momentum in the y. 96 times 2.4 is about 230.4. we'll just say 230 for sig figs there. 230 kilogram meters per second, and 82 times 3.1, about 254.2, or to sig figs, you should get 250 kilogram meters per second. Okay? So this is equal to 250 kilogram meters per second, and this is equal to 230 kilogram meters per second. Okay? Now, how do I find the vector sum of those two? It's not just going to be, say, it's not just going to be 480, nor is it going to be 20. You can't just add or subtract them. They're vectors. But when the vectors are oriented like this, how do we find the p total? How do we find that value? Pythagorean theorem, right? So, Pythagorean, P1 and P2 to get your p total. Okay? So when we do that, it's 250 squared plus 230 squared, about 340. Just write that out here. Once we do Pythagorean, it would be 250 squared. That's how we find the magnitude. (340 kilogram meters per second. So that momentum is going to be going at some angle this way, and they don't even ask for the angle, but we can certainly solve for it if we wanted to. 340 kilogram meters per second. So that's the momentum of this big heap of football players. But we still don't have the velocity. What's the last thing we have to do once we have the final momentum to then find the velocity? Exactly right. Divide by the total mass. So P is equal to mv. So your P total is going to equal the total mass of your mv. So that's 340. The total mass is the combined mass of the two football players. What's that? 170, 178 kilograms is the combined mass of the two football players. Solve for v. So 340 divided by 178. About 1.9 meters per second. When we go to the appropriate number of sig figs. And just double check that that's a realistic number. One was going at 3.1, one was going at 2.4. They're moving together. So yeah, that makes sense. So that's our final answer there.